Alright guys, welcome back to G Tutorials. Let's dive into the world of powers and exponents. So, what exactly are powers and exponents? Think of them as shortcuts in math. Instead of saying 2 times 2 times 2, you can just say 2 to the power of 3. Here 2 is the base and 3 is the exponent. Simple, right? Now, why do we even use them? Powers and exponents make it super easy to handle really big or really small numbers. Imagine having to write out a million zeros. It's way quicker to say 10 to the power of 6. Alright, now let's get into the fun part. How to multiply and divide these bad boys. When you're multiplying base numbers with exponents, say 2 to the power of 3 times 2 to the power of 4, you just add the exponents. So that's 2 to the power of 7. Easy peasy. But what if you're dividing? It's almost the same, but instead of adding, you subtract the exponents. Take 2 to the power of 5 divided by 2 to the power of 2, you get 2 to the power of 3. And boom! You're done!
So the number 3 is the base, and the number of times it is multiplied by itself is called a power or exponent. So power is the same thing as exponent. So power is the same thing as exponents. So we just want to get that clear. After we have watched the definition of power and exponent, we can see how power is the same thing as exponent. Okay, so now we're going to go into whether it's a positive or a negative number. So when we have the negative number as an integer, so the integer, remember, is the whole point of the base number. So any base number is called an integer. So when we see an integer, we know that we have to consider first whether it's a positive or a negative number. So in this case, the first case I just showed at the top, that the 3 being just a 3, the absolute value of 3 is equal to 3. So what if 3 is negative? So in this case, 3 is positive. What if 3 is negative? So we have to determine how many times the number is the multiplied, right? So if 3 is negative, right, in this case, then we have to determine how many times it's being multiplied. So in this case, if we say 3 times 3, if we go back to the rule, right, the rule is negative times a negative is equal to a positive, right? That's the rule. So if we have 2 3s, though it is, the base is negative 3, we have to consider how many times it's being multiplied. So in this case, it's 2 times. So the answer must be positive, okay? Because it's multiplied by itself twice. So this now will turn into the same thing as 3 to the power of 2, right? And 3 to the power of 2 is equal to 9. So that's why 9 is positive, because we're multiplying the negative times the negative, which would be equal to positive. But in the case where 3 was multiplied 3 times, then that will change everything. Because if we say negative times a negative is positive, then a negative times a negative times a negative, it's equal to a negative. And this is why. Negative times a negative is positive, right? And then if we take this positive and we say positive times another negative, that will be negative, because a negative times a positive is equal to a negative. That's the reason why negative 3 to the power of 3, because it's 3 times, is equal to same thing as negative 3. So in this case, it won't be positive 3. So it's 3 times 3 times 3, and that will be equal to 27. And that's a negative 27, okay? So again, when we use negative bases, brackets can become very important. I just showed that to you. It's very important when we use brackets. So in the case where if we say 2 to positive 4, we know that the answer will be 16. Why is it 16? Because it's negative 2 times negative 2 times negative 2 times negative 2. And how many times do we have it? 1, 2, 3, 4 times. That's why the answer is a positive 16. Another way to look at this is, say if we have negative outside of the bracket, that means that, and the power was inside, that would change everything because we're only concentrating on the base being 2, and we're gonna talk about, even though it's positive or the 4 is the actual power, this is how we have to look at it. So we're gonna say, keep the negative out here, then we're gonna put the bracket, and then inside the bracket, we're gonna say 2 times 2 times 2 times 2. And in this case, we're multiplying 2, 1, 2, 3, 4 times. When we multiply 2 4 times, we do get 16. So we're going to put 16 inside the bracket. And we keep the negative from where we had it. And now the answer is going to be negative 16. And the reason is because it's outside of the bracket. So don't confuse the bracket. The bracket is helpful and it's important when the question is written specifically with the bracket showing the negative inside or with the bracket showing the negative outside. So we have to be very, very mindful of that. One more thing we can talk about is the negative bases. After we talk about the negative bases, yes, let's look at the negative bases. So the negative bases is, for example, when the power is an odd number. Remember what odd numbers are? So we have 2, 4, 6. These are even numbers, right? These are even numbers, and odd numbers are like 3 or 1, 3, 5. These are odd numbers. So when we deal with odd numbers and even numbers, these odd numbers can determine when negative prevails. Even numbers, negative they don't prevail because the negative times a negative is positive, and every time you go with an even, you're going to get a positive. When you have an odd number as a power, that will change the sign. If it's originally negative, it will remain as negative. So let's look at negative 5 to the power of 3. When we have that, remember the base is negative 5. So negative 5 times itself 3 times, right? So we have negative times a negative 5 times a negative 5, and that's all to the power of 3. So inside here, we have to do the multiplication. So we know that inside the bracket, it's 125, right? Okay. So let's eliminate this here because inside the bracket, the number is multiplied 3 times. And so when I say inside the bracket, this is 1, this is 2, and this is 3. So we already established the 3, which is 1, 2, and the 3 here. So this is why the answer will remain as negative 125 because we're multiplying the 5 3 times. And because the 5 inside the bracket is negative, we're multiplying the negative inside the bracket 3 times. Now this is going to be different. So if we have -5 and the 5 is inside the bracket as positive, and then inside the bracket, we're saying we want to multiply this 5 3 times, and then we do that. So we have to remember we're going to concentrate on what's in the bracket, just like we did with this one up here. So we're saying 5 inside the bracket is positive. So we say 5 times 5 times 5, right? And we're saying that inside the bracket, all of that is 125. But because outside the bracket is negative, so we have to keep that answer. So the answer will also be -125. So we can see a similarity when it's an odd number, whether it's the negative value is inside the bracket, in this case, number 1, or whether it's outside the bracket, in this case, number 2. When it's an odd number, the answer will likely be the same. And this is proving, right? -125 and -125. So pay attention to that rule. So let's look at another question. So, but before we get into that question, let's remember anything that has a power of 1. So let's talk about that for a second. Anything with the power of 1, if the exponent is equal to 1, then we get the number itself. So example, forgive my scribble on the board. Example, 5 to the power of 1 is also the same thing as 5. And if we say 12, 12 is also equal to the power of 1. So 12 to the power of 1 is the same as 12. So both are always the same. And I just want to add something in there that you probably didn't know. If you had an exponent that is 0, and I know this is probably a little bit advanced, when the exponent is 0, then the answer will always be 1. So let me explain that. In the case I just showed you, 5 to the power of 1 is 5. Well, if 5 to the power of 0, the answer will be 1. And if it's 12 to the power of 0, the answer will be 1. Because any power 0 will make the answer 1, because 0 is not a power really. So the answer can only be 1. The base can only be 1. Well, when the base is 5 and the base is 12 and the base is 1 million, whatever it is, 1,000, the answer will always be 1. So it doesn't matter what the base is, the answer will always be 1. And so that is a bit of what we can talk about with regards to exponents, whether it has a negative base or a positive base. Now we're going to look at multiplying by powers. So let's move this up. So we're going to multiply by powers. So by looking at patterns, we can discover useful relationships for multiplying powers. Let's see what happens when we perform certain operations on powers. Look at what happens when we multiply terms that have the same base. So if we have, for example, 2 to the power of 3 times, and this is key, we're multiplying, 2 to the power of 4. And for clarity, again, let me remind you what I'm doing here. So I'm just going to say what the topic is, because we have moved on to just simply talking about regular multiplication of numbers with the same base. So we're going to go into now multiplying with powers. Okay, so this is the next topic. We're multiplying with powers. So again, we have 2 to the power of 3 and 2 to the power of 4. Now, note carefully that we have 2 to the power of 3, 2 to the power of 4, and it seems similar to what we just talked about. So if we have 2 times 2 times 2, we're doing that 3 times. 1, 2, 3. And if we continue, okay, we're going to say 1, 2, 3, 4. So we're going to multiply 2 times 2 times 2, 4 times. So 1, 2, 3, 4. How many do we have? 1, 2, 3, 4, 5, 6, 7. So it's the same thing as saying this 3 here and this 4 here. It's really saying 2 to the power of 3 plus 4. That's exactly what we just did, which is equal to 2 to the power of 7. And that's multiplying with powers. So if we're saying 2 to the power, let's move on to another one. So let's say if we were looking at 3, since we already expanded, or 2 to the power of 3 and 4, we're just going to go into another example. So if we say 3 to the power of 5 times 3 to the power of 3, we can do it 8 times, or we can just do it by simply adding the powers. So it's simply saying 1, 2, 3, 4, 5, and then we can say 1, 2, 3. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and exactly 5 plus 3. It's the same thing as saying 3 to the power of 5 plus 3, which is the same thing as 3 to the power of 8. So again, all we needed to do was just counter the 5 plus 3. Does this lead to a pattern when multiplying powers with the same base? Of course it does. The pattern for multiplying powers with the same base, it tells us that when we multiply powers with the same base, we keep the same base and add the exponents. And that's exactly what we just did. So similarly, how we added the 5 and 3, and then we also added the 4 and 3. So let's look at some questions just to get a little bit of practice. So what if we did, so the question is 1, 2, 3, and 4. What if we did 2 to the power of 2 times 2 to the power of 3? It will just simply be 2 to the power of 2 plus 3, which is the same thing as 2 to the power of 5. That's simple, right? Adding these two, that's all. 2 to the power, okay, so we have 5 to the power of 3 times 5 to the power of 5. Again, we just simply keep the 5 as the base. 3 plus 5 equals 5 to the power of 8. And then if we were to do 3, number 3 is 6 to the power of 4 times 6 to the power of 2. That's equal to 6 to the power of 4 times, oh, let's not do that, plus 2 equals 6 to the power of 6. Number 4, we say 9 to the power of 9 times 9 to the power of 5. So 9 plus 5 is 14. Okay? And that would be your answer. So if when we have powers that are being multiplied, what do you think happens when we divide powers? When we divide powers, and by the way, let's look at some questions that has negative bases. We need to expand. We don't want to assume that you know everything. So in terms of positive and negative, so if we do the negative power bases, right? We talked about that in the beginning where we talked about positive base and negative base. So let's try negative base. And remember, it's very important to have the negatives on the inside with the powers on the outside. And if that's what's happening, that means the answer will be the same. So we have to keep our bases the same. Okay, in this case, this would be the same thing. So we had -5, and then we have 3 plus 4, which is be the same thing as -5 to the power of 7. Okay, and what if we have -6 to the power of 12 times -6, again on the inside, to the power of 3. We simply add the powers and we have to maintain. So 12 plus 3 is equal to -6 to the power of 15. Okay? And that's it for that session. Now let's look at dividing powers, okay? Because we don't want to just know how to multiply. We also want to know how to divide. So when we're dividing powers, if when we multiply powers, we add the powers, guess what? When we divide the powers, we are subtracting. So now we're going to divide our powers, okay? So the rule is when we do that, we look at the patterns for multiplying with the same base. We can also find a pattern when we divide with the same base. So again, we were using 5 as a base. So let's use the dividing sign, and we're going to put 5 to the power of 2. That will be 125 divided by 25, right? And what will be that answer? The answer will be 5, or we can even say 5 to the power of 1. But what did we do? We said 5 minus 2 equals 5 to the power of 1, which is the same thing as 5, right? Same answer. So that's how we do 5. Any number that's divided with the same base, in this case it was 5, that's how we find the solution, by subtracting the powers when we're dividing. So in this case, we're going to do 3 to the power of 6, and we're going to divide that by 3 to the power of 2. Same thing. We're going to say 3 to the power of 6 minus 2 is the same thing as 3 to the power of 4. Okay, and we can get that answer, which would be equal to 81. And what if we had 8 to the power of 5 divided by 8 to the power of 3? It's the same as, and I'm going to do something else to show you what we can do, another way we can do it. So if we did 8 to the power of 5, it's like 8 times 8, 5 times, right? And we're dividing all of that by 8 times 8 3 times. I'm going to show you another trick. We just simply have to divide it out. So this is what we can do. So we say 1 here. So we're using this part and we're dividing this into it, right? So I just cancel that, cancel another one, cancel one more. How many are we left with? 1, 2. So another way to do it, 5 minus 3 is equal to 8 to the power of 2. And how many 8 did I get? 2. I had 1 here and 1 here. And now 8 to the power of 2 is the same thing as 64. So there's so many ways to do it. And you can do what's comfortable and what's faster. But at the end of the day, you must get the same answer, which is 64. But when we are dealing with unknown variables or unknown bases, this would be a good way to do it by eliminating or subtracting. When we're dealing with dividing. And I also want to bear in mind that dividing can look like using the dividing sign across on the paper, or I could have done it this way. I don't need that highlighter. I could have done it this way. I could have said 8 to the power of 5 divided by 8 to the power of 2. And it's the same thing as 8. 5 minus 2, the same thing as 8 to the power of 3. Okay? So I can do it that way too. So it doesn't really matter which way we do it, as long as we get the same answer. And if we want to do numbers that have negatives, so if we say 2 to the power of 3 divided by negative 2 to the power of 2, we can write it like this, negative 2 to the power of 3 over negative 2 to the power of 2, which is same thing as negative 2. 3 minus 2 equals negative 2 to the power of 1. And that's simply saying that the answer is equal to negative 2. So I hope you have understood the way in which this is just an introduction with multiplying and dividing exponents, also understanding how to deal with exponents, how to handle it. And remember, we're only dealing with bases that are the same. If the bases are not the same, we can't use these rules. So now you can see how to add, multiply, and well, in this case, we're not adding the bases, we're adding the exponents. So adding the base when multiplying and dividing the base, we subtract, okay? So I hope that's very clear. And if you have any questions, remember, you can reach me, see the description box, and you can contact me for further understanding. Thank you.
So there you have it. Powers and exponents aren't just fancy math terms. They're your secret weapons for making math faster and simpler. Next time you see a huge number, don't sweat it. Just whip out your exponent skills and show that number who's boss. Thanks for watching and happy mathing.